if robots are going to venture into remote environments that humans can't reach, such as deep underwater or distant outer space, they won't only require power and a means to get there. They will also need to take good care of themselves. To that end, a team led by Rob Shepard, Associate Professor of Mechanical and Aerospace Engineering and Kernel Engineering, combined optical sensors with a composite material to create a soft robot that can detect when and where it was damaged and then heal itself on the spot. Their paper, Autonomous Self-Healing Optical Sensors for Damage Intelligent Soft-Bodied Systems, is published in the journal Science Advances. Shepard says that their lab is always trying to make robots more enduring and agile, so they operate longer with more capabilities. The thing is, if we make robots operate for a long time, they are going to accumulate damage. And so, how can we allow them to repair or deal with that damage? The first step for such a repair to occur is that the robot must be able to identify that there is in fact something that needs to be fixed. For years, Shepard's Organic Robotics Lab has used stretchable fiber optic sensors to make soft robots and related components, from skin to wearable technology, as nimble and practical as possible. In fiber optic sensors, light from a LED is sent through an optical waveguide, and a photodiode detects changes in the beam's intensity to determine when the material is being deformed. One of the virtues of the technology is that waveguides are still able to propagate light if they are punctured or cut. The researchers combined the sensors with a polyurethane urea elastomer that incorporated hydrogen bonds for rapid healing and disulfide exchanges for strength. The resulting SHeaLDS, self-healing light guides for dynamic sensing, provide reliable dynamic sensing, are damage resistant, and can self-heal from cuts at room temperature without any external intervention. To demonstrate the technology, the researchers installed the SHeaLDS in a soft robot resembling a four-legged starfish and equipped with feedback control. After the researchers punctured one of its legs a total of 6 times, the robot was able to detect the damage and self-heal each cut in about a minute. The robot could also autonomously adapt its gait based on the damage it sensed. While the material is steady, it is not indestructible. They have similar properties to human flesh. Shepard plans to integrate SHeaLDS with machine learning algorithms that recognize tactile events to eventually create a very enduring robot that has a self-healing skin but uses the same skin to feel its environment to be able to do more tasks.